Alright, so now some exam questions on method of differences. So, we have to prove that this sum is equal to that. Now, 1 over r plus 1, r plus 2, r plus 3 is not in any of these forms that we've just done over here. So what on earth do? We can't use any of these like quick formulas. We'll just use the method of differences. So first of all, we'll have to do a big partial fraction decomposition. So we'll get 1 over r plus 1, r plus 2, r plus 3 is equal to a over r plus 1 plus b over r plus 2 plus c over r plus 3. 1 is equal to a lots of r plus 2, r plus 3 plus b lots of r plus 1, r plus 3 plus c lots of r plus 1, r plus 2. Right, let's let r equals minus 1. We'll get 1 is equal to a times minus 1 plus 2 is 1, minus 1 plus 3 is 2. This will be 0, this will be 0. So what we get is 2a is 1, so a is equal to a half. When r is minus 2, we'll get 1 is equal to, that will be 0, that will be 0. We'll get b lots of minus 2 plus 1, which is minus 1, minus 2 plus 3, which is 1. So we'll get b is minus 1. When r is minus 3, we'll get that cancel, we'll be left with 1 equals c lots of minus 3 plus 1, which is minus 2, and minus 3 plus 2, which is minus 1. So we'll get 2c equals 1, so c is a half. So this implies that our sum from r equals 0 this time, right? So it's 0, not r equals 1, it's from r equals 0 to n of 1 over r plus 1, r plus 2, r plus 3 is a, so a half, so a half over r plus 1 minus 1 over r plus 2 plus a half over r plus 3. Now I guess to make things simpler, we'll just factor out a half, so we can get a half the sum from r equals 1, 0 to n of 1 over r plus 1 minus 2 over r plus 2 plus 1 over r plus 3. Now, we're going to start from r equals 0 instead of r equals 1. So r equals 0, we're going to get a half lots of, when r is 0, we'll get 1 over 0 plus 1, which is 1, minus 2 over 0 plus 2, which is 2 over 2, which is 1, plus 1 over 0 plus 3, which is a third. And r is 1. Okay, so now we'll get a half into 1 over 1 plus 1, which is a half, minus 2 over 2 plus 1, which is 2/3, plus 1 over 4. When r is 2, we'll get a half into a third minus a half, which is 2 over 4, which is a half, plus a fifth. When r is 3, we'll get a half into a quarter minus 2/5 plus 1 over 6, dot 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 dot. Now, because we're going up to n, we'll do r equals n minus 1. So we'll get a half into 1 over n minus 1 plus 1, which is 1 over n, minus 2 over n plus 1, plus 1 over n plus 2. When r is equal to n, we'll get a half into 1 over n plus 1, minus 2 over n plus 2, plus 1 over n plus 3. Okay, now, right, so the 1 and 1 cancel out. Now here, if we see here, we've got minus 2/3, and then we've got a third and a third. So the third and third make 2/3, and then the minus 2/3, so all of this cancel out. And it's the same here, a quarter plus a quarter is a half, minus a half is 0. So So that cancels out there. This will cancel out here. This will cancel out. And because it's diagonally, this will end up cancelling out. And this will end up cancelling out. This will start to cancel out, but not entirely, so we're still left with that. So what we're left with is this half over here, and then this over here. So what we get is, and remember we're still factoring out the half, so this half and half will make a quarter, so what we get is a quarter. So it equals a quarter. Now this 2 and this 2 will cancel out, so we get minus 1 over n plus 2. Then 1, now there's nothing to cancel out over here, so we'll get 1 over 2 lots of n plus 3. So plus oh, and we almost forgot this one. So the 2 will get 1 over 2 lots of n plus 2. So this will be before here. So plus 1 over 2 lots of n plus 2. Okay. Right, now at this stage we just have to combine the fractions. If you see here, this is n plus 2 and that's n plus 2. So if we double this one, we'll get a common denominator. So if we double it, we'll get 2 lots of n plus 2 and then 2 over that. So that just makes 1 minus 2, which is minus 1. So what we're getting is minus 1 over 2 lots of n plus 2 added to this. So now, actually, if we just swap this around, so we get this. So we'll get a quarter plus this minus this. So because we've got 2 common in the denominator, we're just going to times by n plus 2, and then we're subtracting the 2, then we're subtracting the n plus 3 all over the common denominator, which is 2 lots of n plus 2, n plus 3. Well, the n minus n will give 0, and the 2 minus 3 will give minus 1. So what we get is minus 1 over this. Now 1 over 4 is 1 over 2 times 2, so 1 over 2, 2. So what we have to do now is, we don't have to multiply this 2 because that's a common denominator, so we're just going to get n plus 2, n plus 3 minus this 2 all over. Now because this 2 and this 2 is common, but we've still got the remaining 2 over here, so it's just going to be 2 times this, which is just going to be 4 n plus 2, n plus 3. And this is just going to be n squared plus 5n plus 6 minus 2, which is plus 4, all over 4 n plus 2, n plus 3. And we have to leave our answer in complete factorized form. So this top one will just factorize to n plus 1, n plus 4, all over 4 lots of n plus 2, n plus 3. And this is our final answer. Let's just check the mark scheme. N plus 1, n plus 4 over 4 lots of n plus 2, n plus 3, that's correct. So that is 5 marks for us there. Now this one, part A. Use the method of differences to prove that for n is greater than 2, this is equal to this, right? So we're now dealing in logarithms, so we've got like a logarithmic series. Okay, right, so we know our log law, so what we're going to get is the sum from, it was from r equals 2 to n, right? From r equals 2 to n, right, we know that ln of a over b is ln a minus ln b, so we can use that rule over here. So we're going to get ln of r plus 1 minus ln of r minus 1. That's what it was, right? Yeah. Now we can't use any of those rules because this is not in the form f of n minus f of n plus 1 or f of n minus f of n plus 2. So we'll just have to do the method differences normally. So when we're starting from r equals 2 now. So from when r equals 2, ln of 2 plus 1 is going to be ln 3 minus ln 2 minus 1, which is ln 1, which is 0. When r equals 3, we're going to get ln of 4 minus ln of 2. Okay, right, so this is what we end up getting. So we can see that the ln 3 and ln 3 cancel here, ln 4 cancel here, ln 5, ln 6, ln 6, ln n minus 2, ln n minus 2, and then before this would be ln of n minus 1, and this cancels with that ln 1 n minus 1. So what we're left with is minus ln 2 plus ln of n plus ln of n plus 1. So the minus ln 2, so we put that like here, minus ln 2, we get is ln of n plus ln of n plus 1 minus ln 2. So that's what it's equal to. Move it a bit over here. Now, just use more log laws, so we'll do the addition first because that comes first in BidMath. So we'll get ln of n times n plus 1 minus ln 2. Now divide that, so that's ln of n plus 1 over 2. And this is what we have to prove, right? Yeah. So that already we know is 4 marks right there. Now part B. Hence, find the exact value of this. Give your answer in the form A ln b over c. Okay. Right, first of all, what the hell, power of 35. Well, we know log laws, just bring that down. And with summation, that will just be 35, the sum of blah blah blah. So what we're going to get is 35 lots of the sum from n equals, r equals 51 to 100 of ln of r plus 1 over r minus 1 Alright, so because we're starting from 51, we're going to have to split that up, so we're going to get 35 lots of the sum from, because here we started from r equals 2, right? So we already have the formula for that. So we'll go from r equals 2 to r equals 100, just 100 on the top, of ln of r plus 1 over r minus 1. And then we're minusing the sum from r equals 2 this time to 50 because our thing here is 51, so we're going to do minus the sum to 50 of ln r plus 1 over r minus 1. Now this is 35 times what we get here, ln of n plus 1 over 2, so ln n is 100 over here, so we're going to get 100 times 101 minus ln, and here n is 50, so we're going to get 50 times 51 over 2, well that's 35 lots of ln of 100 over 2 is 50, so 50 times 101 minus ln of 50 over 2 is 25, so 25 times 51, which is 35 times ln of 50 times 101, which is 5050, divided by 25 times 51, which is 1275. Now 5050 over 1275 is 202 over 51, so we're left with 35 ln of 202 over 51. And A ln B over C, that's the answer, that's the form we had to leave our answer in. Check the mark scheme. So the answer, well, this we know we proved anyway, so that's correct. 35 ln 202 over 51 we got here. So that is 7 marks for us. Okay, I hope this was helpful. Bye.